Alright, today we're going to talk about how I'm going to improve at the Rubik's Cube, and most of these tips can be applied to anything. Step 1. Set aside time. I picked out a half hour after work where I could go practice cubing. So every day I'd come home from work and I'd go over to my desk and start practicing. Showing off my collection there wasn't necessary, but I kind of wanted to. Step 2 is decide what to do at that time. Alright, so I'm planning out my schedule here. I'm thinking every day we'll try and learn two PLLs, 2 OLLs. I'll try and do at least 10 slow solves where I really think through whether I'm doing it right, not necessarily focusing on being fast. And then I gotta go through and practice all the algorithms to get them in muscle memory. Here are the PLLs. I already know A, I already know U, and I already know H. So I guess the first ones we'll be learning are the T and the J1. So for, this Tuesday, I've written down T perm and J1 for my PLLs. And then let's look at the OLLs. Unfortunately, there aren't any nice names for the OLLs, unlike the PLLs, or at least I need to do more research, so I make my own notation for them. So I'm gonna try out these top two. So I'm calling it line double bar and line single bar. So got that right here. Line double bar and line single bar. And then the other thing is I'm going to try and plan out F2Ls tomorrow. So I want to go through all the different F2L cases. A lot of them I'll probably already be happy with the way I do it, but I need to think about the worst ones and maybe try and learn a better way to do it. So I've got my Tuesday planned out. Then I'm going to plan out the rest of the week. And I've got my week pretty much planned out. And then step 3 is to memorize. So to illustrate my process, I figure I'd just walk you through what happened when I actually tried to memorize one of the algorithms. Here you can see the eye open symbol, which means that I was looking right at the steps for the algorithm when I was doing it. And then you see the eyes closed where I was trying to do it from memory. And then the crosses and checks represent whether I was able to actually do it. So as you can see, I was eventually over time able to do it more consistently. I would split this and memorizing in general into 3 phases. So first, it's alien, like you are completely unfamiliar with it. So here you can see that even though I was looking directly at the steps, I was still messing up because I was so unfamiliar with it. After alien, moves over to short term. And short term is where you can do it from memory. It's in your short term memory, so you can do it, but it's not going to be there for very long. Which brings us to the third step, which is long term memory. If you keep practicing it, you'll have it for forever, and it'll be in your long term memory. So that's the progression of anything when you're memorizing. So overall, I was able to bring this algorithm into short-term memory over the course of, 17 tries, and that took me 25 minutes. So I would say this is actually longer than average for how long it takes me to memorize an algorithm, and I think that's because this one was particularly alien to me. It didn't have a lot of familiar patterns in it for me, and also it involved a lot of L turns, which I'm just not very comfortable with in general. I'm much more comfortable using my right hand. This algorithm was the left-sided R permutation, and we can compare how long it took me to memorize this one to how long it took me to memorize the right-sided R permutation. And as you can see, I did much less tries, and it only took me 10 minutes. And that was because this one involved right-sided turns, and it was like the mirror image of the other one, so I didn't have to do all the work in rememorizing it. I could just recall the left version. So next, I'd like to talk about some of the strategies I use for memorizing algorithms on the Rubik's Cube, and also generally. So, the setup we have here, this is the situation where we would use the R permutation. The R permutation where you swap these two and these two. The first tip I have is chunking. So the left R permutation is 13 moves long, and to memorize 13 moves is quite an ordeal. There's some sort of psychology study that says that you can only hold up to 7 items in your short-term memory. So 13 moves is too much. So what you can do to fix the issue is you can use chunking. So you will group the moves together so that you can think of each group as one item. You can reduce the number of items down to a number that you can hold in your short-term memory. For this algorithm, the first chunk is I do left forward, I do top 2, left back, top 2. So I can remember that. There's a fairly good pattern. I can remember that's one chunk. Next one is left forward, and then I turn the front counterclockwise. That's another chunk. And then my third chunk is the left sexy move. So that, wait, shoot, live recording. Okay, left sexy move, which goes like that, I think, I hope. And then, so you can see I did those 3 chunks, and although those were several moves, I was able to remember it just as 3 items. So that's how you can use chunking. So for the 4th chunk, I'd like to mention, we're getting into the second tip, which is find patterns. So if you can find patterns, then it becomes, then you can also reduce the memory. So in this case, the next chunk is to go left forward and then put this clockwise, the front clockwise. I can remember that really easily because I can think of it as just the opposite of the previous one. So earlier we had a left forward, right counterclockwise, and now we have another one where it's left forward and then clockwise. And it's fairly minor for this algorithm, but there's some algorithms where you essentially have a series of 4 moves, and in the beginning you have those 4 moves, and at the end you have those 4 moves backwards or mirrored or something like that, or even the exact same sequence. So if you can see the algorithm and like go ahead and find those patterns, then that will also make memorizing it a lot easier, because you can essentially, like, in some cases you can cut the algorithm in half in terms of how much you need to memorize. And this brings us to the last chunk, which is to do the left U2, and then we just have to do an adjustment to have it solved. And there we go. The next tip I have is familiar association. So the idea here is that you try and find aspects of the thing you're trying to memorize and associate with stuff you already know. Up until now, the tips have been involved with like memorizing the actual moves in the algorithm, but another step that's important for getting fast solves is to have good recognition time. So if I look at this, I need to be able to quickly see what the correct algorithm to use is. That's my recognition time. A way that I'm using familiarize, whatever I called it, is to is to take advantage of the name of this algorithm, and it's called the ant. If you use a little bit of imagination, you can imagine there being 2 feet on either side with the antenna over here. So that's an ant, and here you have the body. So that's one aspect. I had the visual of seeing it as an ant. That helps me recognize it quickly, and it makes it more fun too. So the other thing is I actually have a little aid to remember the algorithm as well. So the algorithm is to do front and then do reverse X move twice, and then I can do front counterclockwise. And this is nice because I can use one of the old 90s songs to remember it. So when you see an ant, I'd like to go back to our diagram here. So as you can see, I got it wrong a lot in the beginning, even though I was reading the algorithm. During that period, I was trying to apply these various short-term memory strategies and try and find patterns and chunk the algorithm. But I was having difficulty in the beginning, like finding patterns. So I would find false patterns, I would get it wrong. And then when I finally figured it out, I was able to do it from memory using those patterns, and then it was just a matter of reinforcing it so that I can hold it for at least a day or so. Next, let's transition over to tips for long-term memory. So there isn't really much to it. In order to get something in long-term memory, you use spaced repetition. Practice it a lot in the beginning, and then continue practicing it at increased intervals over time. If you do that over a long enough period of time, you'll get to a point where what you're trying to memorize is burned into your memory. So for Rubik's cubes, like you'll say, the algorithm is in your muscle memory. So this is one of the two-look OL cases, and when I see this, I just do the algorithm, and I can't even tell you what the moves were that I just did. My fingers just know to do them at this point, so it's just burned into my memory. Even once you have it burned, though, you need to be careful, because I've experienced this phenomenon where more recent stuff that you've memorized tends to override stuff that you used to know. So for example, the clockwise U permutation is something I memorized. Starts with the U2 and the right top, and then there's this sexy move, and then there's the rest of it. So the fact that there's like a sexy move in there kind of threw me off. So if I fix this, so there's another algorithm I learned later called the T-perm, and that starts off with a sexy move, and then it does the rest, and I can't do it live because I'm still that one's still pretty recent. Yeah. Alright, I fixed it again. So yeah, the problem was that when I started learning the T perm, I'd do the start of the U perm, and then do the sexy move, and then I would transition to the T perm because that's what my fingers were used to doing. So yeah, I got to keep practicing this algorithm, even though I'm comfortable with it, because I need to make sure that the new ones don't override it. I'd like to run through an example of how these concepts might apply to memorizing vocabulary. So let's say you're preparing for the SAT, and your SAT word that you want to memorize is abrogate, which means to revoke formally. So you could use, one of the tricks you could use is using a visual aid. So I could see gate and visualize a gate, which is revoking somebody from a castle or something like that. So there you go. The gate can be a visual cue to that word. Chunking is another thing that's commonly used for vocab words. Not so much this one, but if I'm learning a foreign language and I'm learning the word bike, I might learn the word ride at the same time. I can chunk those together and essentially get two words with the effort of learning one word. And back to abrogate, after you get good mnemonics for memorizing it, you have to do spaced repetition to get it to sink in. There's a good wiki page talking about spaced repetition, and there's also a lot of good apps specifically for flashcards of vocab. I would personally recommend Anki. I think that's a really good one. And as you practice it more, you can eventually get to a point where you have it burned, where you're not even thinking about your mnemonics anymore. If I say the word elephant, you should immediately get an image of an elephant in front of you. The connection between the word and the thing is so strong that you immediately see it. But as you keep drilling it more, you can also run into that overwrite issue with these types of words. So you have abrogate down, but then you might come across a new vocab word, which is arrogate. And for me, if I saw arrogate after being familiar with abrogate, the first time seeing arrogate, I might not even notice that it's a different word. I might just immediately see gate at the end and go for the abrogate definition. But at this point, I would need to kind of diligently study both of them and kind of recognize the differences and move on. Because otherwise, if I don't keep studying abrogate, then arrogate would pretty much just take over as the default definition. So that's how these concepts can apply to memorizing vocabulary. And that's probably good for now. Next time will be an update video covering the progress.